So day 3 of this same kind of stuff. Not a lot is changing today. The equation is still like scale. You're still always going to do and whatever you do to one side, you do the other, and it's still smart at the end if you check. The difference today is going to be that there's 2 steps going on. So day 1, we only added or subtracted. Day 2, we only multiplied or divided. Today, we're going to have to do both things. So the first question, I guess, would be, does it matter what order you do the steps in?
Yes.
Yes, it does. So on a problem like this, because of what the 4 is doing, at some point, what are you going to have to do?
Divide by 4.
Divide by 4. At some point, because of what the 10 is doing, you're going to have to
Subtract by 10.
subtract by 10. So then the question becomes, what are we going to do first out of that? Does anybody have a theory on whether you should do the divide by 4 first, or whether you should do the subtract by 10 first?
We're going to work on getting the 4x along, so we subtract 10 first.
You are going to subtract 10 first, that is correct. If there's 2 things to do, we're going to add or subtract first, we're going to save the multiply or divide for second. Why to some people does that sound wrong?
Because the 4x is first, and it's the opposite of the order of operations.
Okay, what were you going to say?
I was going to say the opposite of the order.
Yeah, the order of operations is the key to the thing. So a month ago, or whenever that was, we learned that for the order of operations, last place was
Subtract.
adding and subtracting. And now I'm coming in and saying that in first place is now adding and subtracting sometimes. So what's up with that? Like, I didn't lie to you. The order of operations was a thing. Why did the order of operations just like get all turned inside out?
Because we do the opposite.
We're doing opposites. We're not just going to have to do the opposite stuff. We're going to have to do it in the opposite order of what you did. It's kind of like someday when you're driving. I don't think any of you are in here driving, but if you ever drive somewhere and you have your phone mysteriously breaks and you have to like actually know where you're going. When you come back home, if getting there you turn right and then left, when you want to come home, you can't turn left and then right. It's not enough for you to just switch your turns to be the opposite turns. You also have to do them backwards. So you'd have to, if you turn left last, when you come home, you have to turn right first. And if you started off with a couple rights, then you have to finish with a couple lefts. It's not the same if you just reverse the stuff. You also have to reverse the order. And that's what's going on for us today. So I'm still going to want you to show the work and do what we're doing. So what did we decide we were doing about the 10?
Subtracting it.
Subtracting 10. So I'm going to subtract 10 to eliminate the 10. And then where is my other subtract 10 going to go? Because all of a sudden we have more choices about where to put that.
22.
Under the 22. Because one of them was on one side of the equals. So we've got to get on the other side of the equals. Math it up. This makes 12. This leaves us 4x. And then what did we decide about that 4? We divide. Divide by 4s to eliminate 4s. Grand total 3. Check it. 4 times 3 makes plus 10. Check. Question about what's up with these 2-step problems. So just do some more. So what's our first move on this?
Add 8.
Add 8. We get rid of 8s. Also do that under the 5. Creating 13, but leaving 3x. Then you're halfway home. Then
Divide by the 3.
divide by the 3s. Gets rid of 3s. And if you were in 7th grade, I'd make you say 4 1/3. But now that we've grown beyond that into the high school world, just leaving it 13 over 3 is completely fine. And I'll make you the same deal as yesterday. If you get a fraction, I'm not going to make you check that. I'll just be nice to you. But if we did check it, it's not actually that bad. What would happen when 13 thirds multiplies 3? What nice quick thing just happens? If 3 multiplies this. Just cancels the 3's. and we'd get 13 minus 8 is 5. That one's actually not bad at all to check. Something there. So much fun, let's do it some more. So first move here,
Minus 3.
subtract the 3, also from the 1. Be careful with your negativity, because this is going to go negative 2. Leave 2x alone.
Divide.
Divide by regular old 2. 2 is gone.
-1.
Negative 1. And then check it. 2 times negative 1.
Negative
Negative 2 adds 3.
2.
1. Okay. This one. What's up first?
Plus 7.
Adding.
Add the 7. Both sides. 7s are out. 3x is left. Careful in your adding rules. It is negative 7.
Divide by 3.
Divide by 3s. Simplest thing to put is
-7/3.
-7/2. Not bad to check again. If we, I won't make you, but if we did check this, what nice quick thing would happen?
Cancel.
Cancel the 3s. So we'd have -7 minus another 7. Is -7 minus another 7 working for us? Yeah. One more, and then we'll have the camera shift. First move here,
-5.
subtract 5s. 5s are gone.
-2x equals -9.
-9. Yeah, be careful of our subtracts and negatives, but yeah, you got that one.
Divide by 2.
Divide by -2. Negative dividing negative makes positive.
9/2.
9/2 is fine. If we did want to check again, the 2's would just cancel. So we'd have a -9 adding 5. Does -9 adding 5 hold up?
Yes.
Yes. Question about that first group before we swivel? Can somebody front row swivel me? I think I just ran out of room, didn't I?
Mm-hmm.
Okay. Yeah, just try to swivel it to get the rest. Thank you. This one will be your first move.
+10.
You'd think that, but you see the minus and you see the 10, you think add 10. But if I add 10, would that kill the 10?
No.
What would it make?
Make it 20.
It would make it a 20. So I went out of order and that like made us stumble for a second. So how can you get rid of a positive 10?
-10.
We'd have to minus 10. And over here we go minus 10.
So
10s are on,
-2x is -3. Wait, is that a -20?
20 minus 10.
It's just 10.
Yeah, that's my equal sign got a little carried away.
So 10.
That is going to be a 10. Then
Divide.
divide by
Negative 2.
-2's. Good to bring in the negative with us there.
-5.
It is -5. So -2 times -5,
-10. Or just 10.
positive 10. A positive 10 and another positive 10 is a 20. Something there. Here's another one that it's like kind of backwards because now the variable's not on the left, it's on the right. If that makes you super mad, just don't copy the problem with this. Put the =3 here instead of there. But if it doesn't bother you, just live with it. We first want to
+1.
add 1. Gets us 4.
Equals 6x.
Agreed.
And then
Divide by 6.
Divide by the 6. 6 is gone.
2/3.
2/3 is our best answer. That one be a little more hassle to check because it's not as perfect of a cancel, but it would be checkable, but you don't have to check any fractions. Something there. Another one that's backwards, so to speak, we
-11. Add 11.
Plus
add 11 to get rid of that 11 doing the opposites. Adding rules, be careful, negatives, positives, adding rules, we
7.
settle on 7.
Divide by -5.
Divide by -5s.
-7/5.
-7/5. and this is a conversation we had another day, when I go to write the negative, I could either put it
On the top or the bottom?
on the top or the bottom, or even
In between. Wait, not in between.
just kind of like out in the front, not with really anybody. Just make sure you get a negative tossed in there, but whether it's top, bottom, or just way to the front, doesn't make any difference. Fractions can make people mad, so here's one with fractions. First move,
Minus 1/5.
subtract the fifth. And then maybe we need to run a fraction seminar. Subtracting fractions, you have to have a common denominator. We would choose here 20. And if you're going to change the bottom, got to change the tops. 15
And then 4
and a 4. And then we're subtracting. 15 subtracting 4.
is 11.
11
Over 20.
over 20. We'll pause there, make sure we didn't lose anybody in fraction subtraction count. Things like that was bad news. Then how are you going to clear the 2/3 out of there?
By multiplying.
Maybe, if you keep talking.
Ooh.
You switch it?
So we're going to flip it, correct. So if you said divide by 2/3, I'm with you. If you say multiply, I'm maybe with you, but only if you flip it. So we're dividing a fraction, it's going to flip it. 3 over 2 wants to multiply to make complete elimination. Over here, 3 over 2 is going to multiply 33 over 40. If you want to check it, it's like humanly possible, but I'm not making you do that. That would be kind of a drag. Questions about that? Final one of the day, we've got parentheses there, so the question becomes, what do we do with that? We're very used to...
Distributing?
Yeah, we're very used to when we see parentheses, we're supposed to do that stuff first. Even though our order of operations is somewhat out of whack, you still want to deal with parentheses first. So distributing is the right call here. If you distribute this, you get
5x plus 25.
5x plus 25 equals 12. Then settle into our normal mode. We've been in the whole beginning part of this period. Subtract the 25. So 5x is left to equal
Negative 37.
positive 12 subtracting 25.
Negative 13.
Negative 13 is true.
Divide 5.
Divide by 5s. Zip, zap.
Negative 13 over 5.
Negative 13 over 5. And again, no one cares where the negative goes, top, bottom, front, wherever. One more, distributing a half shouldn't make you mad. What happens if you distribute a half in just basic terms?
It's a little 1.
What'll the 12 become? Let's just start with
6.
that. It'll be a 6. What'll the 8 become? 4. Distributing a half, it just did what to the numbers?
Minus 1.
Cut them in half, or in other words, divided it by 2.
Two.
So distributing a half, just cut them in half, divide by 2, however you think of that. So distribute the half equals 1,
Subtract the 4.
subtract the 4s, so 6x equals
Negative 3.
-3, then
Divide by 6.
divide by the 6s, eliminate 6s, x would be
Negative 5.
negative half is perfect. And last thing of the day, there'd be 2 ways to do this problem. Okay, if you're more comfortable solving for x, you could do that. You know, do your opposites, figure out what x is, plug it in, 10 times that, add 6. That's going to be a long road. I would not encourage you to do that if you can figure out what they did. Can anybody see what I did when I created this?
2.
Did what with 2?
Multiplied it.
I multiplied by 2. I just took the left side and I multiplied everybody by 2. So if I'm going to multiply the left by 2,
The right.
multiply the right by 2, and you get
14.
14. Question about that? Here's something I could have done to be meaner. Some of the homework is meaner. Let's say I went like that. Now I didn't just do one thing. Now we're going to have to start to like do some other stuff with this. So if this side I like multiplied by 2 and I switch some other stuff, we can't instantly pop an answer anymore. But what we could do is try to solve. So if we tried to solve this, you'd first
Subtract the 3.
subtract the 3, and so the 7 would become
4.
4. Then see if we can jump. This had 5x, this has 10x. So if 5x turned into 10x, 4 would have to turn into, just ignore that for a second. If 5x turns into 10x, 4
8.
would have to turn into 8. We'd be looking at an 8 for a second. Anybody confused about the 8? But then under my hand is this. So we're not thinking 8, acknowledging that.
Say 12.
We're thinking 8, then
Negative
use that.
8.
2.
2. Because I have to take the 8 that's in my mind and then
Subtract.
subtract 6. That would settle in to get us a 2. If you didn't like that, if I lost you in that, keep solving it the whole way out. You could solve this to get x equals some kind of fraction or decimal or whatever it turns out to be. 10 times that minus 6, it will be 2. I just think that's a hassle. If you can avoid solving it all the way, I would not. But you do what you do. You develop your own style. That's part of what you're trying to accomplish here over the year. Where we are, homework stuff, 108, we're going to go 1 to 24. 1 to 24 is going to be like all this beginning stuff that we did, including, I think, a little bit of distributing toward the end. Then we're going to skip a bunch and go from 31 to 34. 31 to 34 is like what I did in this very last little corner once, and then I tweaked it into being a little bit of a trickier move. But 31 to 34 is going to be like that little corner. 1 to 24 is more of like the so-called maybe normal problems. Just make sure you add or subtract first, multiply or divide second. Should be in business. Show some mark, do some opposites, do some checking, all that stuff. Question about any of that life?